This is a demonstration of Vision Engineering's direct comparison overlay module for the M3 measuring software. The direct comparison module is essentially split into two parts. The first part will allow you to import an existing DXF file and modify that file for overlay purposes using the M3's measurement, construction, and dataming functions. The second part of the module will allow you to import that saved DXF file and use it as an overlay for a direct comparison to the part. To start with, I'm going to import an existing DXF file and modify it. To do this, I click on the M3 icon, open, and I change my part type from part file to DXF files. And my DXF file for this demonstration is located on my desktop, and I click open. I can tell the import program or the import module which layers to import. In this case, I'm going to import both layers in my file. Next are units. I need to specify the units the DXF file was originally created in. This can be inches or millimeters. Please remember that DXF does not contain the units information at the header of the file, so this needs to be specified by the operator at time of import. We can also mirror the file. We can mirror it in the x-axis, the y-axis, or both of the axes. And the scale. A scale of 1 is 1:1. If my CAD file was twice the size, the scale would be set to 2. If it was half the size of the part, the scale would be set to 0.5. When I'm happy with these settings, I push Done to import the DXF file. Once the import is complete, you will notice over on the right hand side in the feature list all of the features, and to the immediate left of the feature name you have DXF in blue. This signifies that this feature came from the DXF file. I'm going to click on my part view now, and I'm going to edit this file. What I'm going to do first is I'm going to move my datum origin from the bottom left to the top left. To do this, I'm just going to use the M3 measuring software's datum functions. I'm going to measure a skew on the top line and hit Done. Then I'm going to create a point of origin or an intersection point from the left line and the top line and hit Done. And that has moved my datum from the bottom left to the top left of the part. Next, I'm going to clean up this DXF file and just leave the features there I want to use as an overlay. The easiest way to do this is to select all of the features in the file and then unselect the ones I wish to keep. Once I've selected the features I wish to keep, I push delete and it will remove everything else. Now what I'm going to do is use the new profile function to put my features into profiles. I'm going to select the slots and the three circles, and I'm going to create three sets of different profiles. To do this, I select Profile, and instead of trying to measure a profile, I select the features I wish to create the profiles out of. My first profile I'm going to create out of these 8 slots, or the 8 small slots as I shall refer to them from now onwards, and I hit Done. My next profile I create from these 3 slots, and I hit Done. And my third and final profile I shall create from the 3 circles, and I hit Done. Now the next step is to apply tolerancing to each of these 3 profiles. To do this, I select the profile, and then I select the feature detail of a profile. I can then add my profile tolerance at the bottom of the screen, and I'm going to be very generous with my profile tolerances for demonstration purposes. Set profile 75 next, click on my feature detail, tolerance, profile 76, feature detail, and again tolerance. Now I go back to my feature detail. You'll see that I have red lines and yellow lines around the feature nominals. My red lines represent the dark and my yellow lines represent light. And in the case of the small slots, these are the correct way round, but on my other features this is the wrong way round. To change this, I click on this new icon here, which changes polarity of dark to light, and select the features or the profiles I wish to change. Now I've done this, all what's left for me to do now is export this as a new DXF file. To do the export, click on the report view, export DXF, and I'm going to call this overlay. And I hit save. Before I move on to the second step, what I need to do is do a new part. This will erase all the data out of the system. The next thing I need to do is set up the part coordinate system the exact same way as it is in my DXF overlay file. Remember that I moved the datum to the top left hand corner. So I'm going to do the same. I'm going to select my top line here, measure that as a skew, and done. Then I'm going to measure the left side as a line, and hit done. Now what I'm going to do is go to my part view, and I'm going to create my point of intersection and make that an origin. Now my origin is in the exact same place as it is in the DXF file. I'll click back on my video view, and I'm going to change my probe now from touch to measure to overlay. The overlay probe always shows up as a crosshair first. This is the default setting. To change it to my overlay, or to my overlay DXF, I click and hold on my direct comparison probe button. When the Open DXF File dialog appears, I select the DXF file I wish to use, in this case Overlay, and I click on Open. The next thing I need to do is pin the overlay to the part coordinate system. To do this, I have this tack pin icon. I click on the pin icon and that pins the overlay to the part coordinate system. As you see here, my overlay for the slots is shown. We'll move over. Here's the overlay for the large slot. And finally for the circles. I'm going to move back to one of the slots, this one here, and I'm going to demonstrate some other additional functions that we have. We can move the overlay laterally from left to right or up and down. When the overlay is out of position, or the part is out of position to the overlay, you'll see a thick red band showing where the error edge is. You can also rotate the overlay. If you click on Rotate, we have a new button here which allows you to select the pivoting point for which to do the rotation. This concludes the demonstration of Vision Engineering's direct comparison module for the M3 software.